that note sheet and I'm going to draw in some details of what's happening. Theoretically, it does. Alright, so. Is that right on the camera? See that? God, you're having a little trouble. That's good enough. Did you lose much of the video there?
No.
Okay. So, we're going to start with the conduction demo with the electroscope. And when we started, this electroscope here was neutral, meaning I'm just going to draw positive, negative, positive, negative. It was balanced out, it was neutral, nothing really going on. But then I charged up my wand. And I charged my wand in such a way that it had an excess of electrons. It was very negatively charged. Now, when I brought it close, you notice that these started to twitch outward before I'd even touched it. What is going on there? Well, what you got to remember is that like things repel one another. So, there were some negatives here and here, let's say. Don't draw those in your picture. They were here and here, just for instance. So when this negative came close, it started pushing these negatives down to the bottoms. Now if you have a negative here and a negative here, they don't like each other either, and that starts swinging these outwards. So see, what has happened is the negatives have traveled downward. They're being pushed by the wand. Right? Does that make sense to everybody? I'm going to have to kind of erase in order to slide this up again. The next picture is the kind of the punchline of the demo. We have this negative wand, and we actually touch it. And when we touch it, the negatives, why don't they just go to the ball and stop? Well, metal's a conductor, but why don't they evenly spread themselves out there? Don't draw that. Yeah, but the positives, remember, I should have drawn that on all the pictures. The positives are where they are. The positives don't move, because that's the material itself. That's the nucleus. There's positives in the wand, too. We're just ignoring them because we have such an overabundance of negatives in comparison. So positives are just there. But why do these negatives not stay up here? Why do they end up going down here? Because it seems pretty obvious that they end up at the bottom, because these two things totally swing apart. They're trying to get as far apart from one another as humanly possible, as physically possible. So they push apart like that. Why don't they just stay up there? And the answer is because there's still a lot of negatives up here. Just because I touched the wand there doesn't mean all the negatives drained onto the electroscope. There's way more than can fit on the electroscope. So they go down to the bottom. Other ones stay on the wand and they separate, and there's really just like a normal number of them on the actual stem and on the sphere on the top. Is that picture making sense to you? That's a conduction demo. And conduction by actual definition means, you're moving electricity or electrostatic charge by touch. You're actually physically touching conduction. Alright, moving to the next one. It's on the other side of the class's note sheet. We have more pictures this time. And we'll start at the top here, number one, very simply. Number one, Lou touched the pith ball. Lou, by doing this, he equaled out, so this has an equal number of positives and negatives, because he is acting as, here's the symbol, new symbol for you, a ground. Okay? A ground is like a long line with shorter lines underneath it, meaning he is just neutralizing it out. Good to go. Second picture. Second picture, we got a negatively charged wand, which is being brought close to the pith ball. There was a little bit of an effect. The pith ball was kind of dancing around a little bit, and that's probably based on the fact that you have, a positive and a negative on the pith ball. The positive is a little bit attracted to the wand, and the negative kind of pushes to the other side, so that the positive actually kind of wins a little bit. You know what I mean? Because you notice how it was kind of following the wand. So since the positive is closer in vicinity, it starts following the wand. So there's a little bit of attraction here, but it's minor. We move down to the next picture. I'll do the next two pictures actually. And in picture number 3, Lou actually touches the pith ball while the wand is there. So remember, the wand is really negative. It's affecting the negative. We had one negative that was here, and the positive was here. That's the way we've drawn our pictures thus far. So where is that negative going to go when given the opportunity? I'll just draw it like this. The negative is going to travel right down his hand into his body. He doesn't really feel it because it's really not enough to notice. But that negative goes down this way. And so as soon as he pulls his hand away, next picture, now this thing is just positive. You've drained the negatives right off of it. And since you drain the negatives off of it, and the why did it do that? There it is. Okay. Since this is a positive that's left behind, and this is totally negative, these are totally, strongly attractive. Leaving us with the final couple pictures. We move over here. Alright, the final couple pictures go something like this. Let me redraw this picture. Alright, now, in this picture, it's touching. Now the wand is touching the pith ball. So what do you think's happening? Remember, there's a lot of negatives on the wand. Where do you think some of those negatives are going in order to get away from each other? To the pith ball. So now the pith ball is starting to gain some negatives, but it still has a positive. But it's gaining negatives, so then in the last picture, the pith ball goes whipping away because now, what is the pith ball? Basically negative, and the wand is still negative. So now there's a definite repel. So this process I've taken you through is called induction. And induction is when you're moving charge around, yet, remember back to the beginning, when you were looking at these beginning pictures here, the wand actually never touched the object, yet you were able to move charges and it never actually touched it. That's how induction works in comparison. So we got conduction, induction,